welcome you all to the new video on production technology series. So this video we are going to see about the classification of cutting tools. So with a short recap, in the first video we discussed about what is manufacturing and what is production. We saw few manufacturing processes, generally what will be used in giving or value addition for any raw material. Then in the second video, we saw about the types of cutting, the nature of cutting. So that is two types, orthogonal cutting and oblique cutting. So in orthogonal cutting, we'll be using a perpendicular angle, and in the oblique cutting, we'll be using an acute angle. So the angle will be maintained between the workpiece and the tool. So with this, we wound up the previous session. And now we are going to discuss about the cutting tools. What are the cutting tools that will be used to remove metal from or remove chips from the workpiece? So here we have been classified four different types. That is generally a single point cutting tool. Multi-point cutting tools are classified based upon the number of cutting edges, the point where the cutting actually takes place, because we may be having an entire tool. We'll see the tool signature in the upcoming slides, but the tools, single point cutting tool will be the single one primary edge will be removing the material. And in multi-point cutting tools, we'll be having more than one tools. It may be 5, 6, or it may be 10, 12 also. There may be number of multiple points that can be made. In solid versus tipped and indexable inserts, those are types where we'll be modifying a single primary material to a cutting tool, where the solid edge, the complete material will be used as a cutting tool, or the end tip may alone be used as a cutting tool. Indexable inserts will be having the entire shank to be of some other material, and the end tip alone will be of a harder, much harder material. So that is depending upon the cutting edge. So here we have shown a single point cutting tool, though the image showed on the left side is just a indexable insert type. So we'll be having a shank or a shaft, and a harder metal small piece alone will be used in the tip. This is because to decrease the uh, cost of the cutting tool, and to increase the efficiency or performance of the cutting tool. So we can see if the other metals may be if the other metals may be of HSS material. So we can see here, if those are high speed steels, HSS, and this alone, this part alone is the, you can see the dark metal, that is alone, it is titanium. So we can imagine, if the entire piece is of made of titanium, then the cost incurred will be much higher. So when compared to high speed steel and titanium, the amount of titanium required will be lesser. So that edge alone can be replaced. So that is the advantage of indexable inserts. So here we can see a complete tool, single point cutting tool. In a single point cutting tool, the entire edge is not, entire piece is not going to cut or remove metal, only the edge here. So this is the cutting edge that is going to remove material. It is going to involve shearing force or action on the workpiece. So we can see other parts that has been named. So the base, the shank, side cutting edge, and the face of cutting, the nose of cutting, and the major flank and minor flank. So basically the adjacent or an opposite surface to the cutting surface will be the flank surface. Tool signature. What is tool signature? What is a signature? A signature is that specifies or denotes something, right? So if we have a signature, then that signature specifies me. It specifies the current particular person. So likewise, to signify or to specify a specific tool, we have a tool signature. So what are the parameters that can be used in a tool signature is a numerical code. A standard code depends on the angles of cutting tool. Then geometric specification, the tool geometry may be crucial for cuttings. The angles, active angles, then the material, high speed steel or tungsten or carbide or titanium, whatever may be, it can be specified with the tool material. Then the tool signature is other parameters are the angles, rake angle, side rake angle, relief angle, and the cutting edge angle. So we can see what is rake angle and what is flank. So the edge or the surface that is going to interact with the workpiece, or it is going to interact with the chips, it is going to affect, it is going to be affected by the shear zone. That surface is called as a rake surface, and the opposite or adjacent surface is going to be the flank surface. This is called the flank surface, and this is the rake surface. So the angle maintained in the rake surface will be rake angle, and the angle maintained in the flank surface will be the cutting relief angle, clearance angle. It is also called as a clearance angle. And other systems that is generally followed for tool nomenclature is ASA system, that is American Standard Association. ORS is orthogonal rake system, and NRS is numerical normal rake systems. So all these are generally used, but the primary predominantly commonly used system is ASA, American Standard Association system. So those systems specify the angles and the system. Then the differences between rake surface and flank surface is shown here. So the hot or sharp chips, the surface that is going to be interacted with the chips is called as the rake surface, and the other edge will be the cutting surface. So since the rake surface is maximally contacting the shearing zone, it will be worn out easily, much easily than the other surfaces. So other parameters are defined or briefly here. So in general, to achieve machining excellence, we'll be having the chip formation has to be understood, the cutting operations, the tool life, and the enhanced machining surfaces. All the parameters has to be attained, and it has to be achieved so that overall better performing machining can be achieved. So we'll discuss in the future slides. Thank you.